Okay, so hi, thank you for coming in. On Sunday, we are going to go over geometry review. I have a ridiculous amount of questions for us to do, so we aren't going to necessarily do all of them. A bit of warning, I will say I have misplaced it, but it could very well have been Freddie, have misplaced my drawing pen. So my writing is going to be even worse than normal because I'm using the mouse. But we're going to be fine. What I'm going to do a little bit differently than before is usually before I tell you all of the standards that we're supposed to know, and then we do questions. What I did this time in my presentation is I have like a standard, and then I have questions, and then I have a standard, then I have a questions. So if you know the standards, then you should know the most important or the most salient points that you need to know for your test. Tomorrow, you're going to be taking your strategies test. We're going to take, in my class, because I think all of you are my students, we'll be in E412 tomorrow, E412. We'll be there for first, second, third, and fourth. So the plan is first period you take the strategies test, first and second, and then third and fourth we'll work on Delta Math that's specific to the test we're going to take on Tuesday. And that test we're going to be back on, I think, A105. So only Monday is when we're going to have to be in the other room. All right, let's get started. So the first AKS that you are expected to know are things about lines and angles. And this is kind of what's so frustrating for some of you because we did this standard probably 3.5 weeks ago, almost 4 weeks ago. It was the first standard we did the first week of September. So we are going to go over it. Again, I have a lot of questions relating to it because I want to make sure that you feel confident with it. Now, here's the thing. Take a picture with your phone of this because if you know all this information in the standard, you will end up knowing the test. So vertical angles are congruent. You need to know that piece of information. When a transversal crosses parallel lines, we have alternate interior angles and we have corresponding angles. Those are the types of things that you're going to have to be able to identify. So we know we talk about vertical angles, we're talking about alternate interior angles, we're talking about corresponding angles. Then we have to talk about perpendicular bisector. You learned that if we have a perpendicular bisector, it forms like an unlimited number of isosceles triangles above and beyond. And then we'll look at that. Also, again, knowing vertical angles are congruent, alternate interior and corresponding angles, and then the perpendicular bisector. So let's look at some questions. Okay, so it says transversal EF intersects line AB and line CD as shown in this diagram. What could we do to prove that these two lines are parallel? So I'm going to have you get into chat and go ahead and tell me what you think you would pick for this one. Which of those angles will tell you that you have parallel lines? Okay, no one's brave yet, so I will walk you through it. So let's just look at what the types of angles are. When we have angle 2 and angle 4, this is angle 2 and this is angle 4. Vertical angles form an X. So these are vertical angles. Vertical angles have nothing to do with parallel lines. Vertical angles happen anytime you have two lines that intersect. So because it says we're trying to get parallel, the fact that it says vertical angles, that doesn't help us at all because vertical angles have nothing to do with parallel. The next one says angle 7 is congruent to angle 8. So if we look at 7, well, there's two things that we notice. First of all, angle 7 and angle 8 are supplementary. They form a linear pair. So that doesn't help with parallel lines because I could draw a single line and write 7 and 8, and I don't even need to have one parallel lines in it. So first of all, 7 and 8 are not congruent. And second of all, they form a linear pair that has nothing to do with parallel lines. Then we're left with angle 3 and angle 6 are supplementary. So here's angle 3, here's angle 6. That is actually not one of our AKS, but that is true. That's the day that I did the stutter on purpose where I was like same side supplementary. These are these are same side interior angles, same side supplementary. So since I have same side supplementary, I know that choice 3 is the correct answer. For choice 4, it says angle 1 and angle 5 are supplementary. Well, first of all, angle 1 and angle 5 are corresponding angles. They're corresponding because if I somehow magically took this entire thing here and I translated it down, it would map on top of here. We did an activity of that where we had to translate on patty paper. So if that translated down, these two would be corresponding. And we also know that corresponding angles are congruent. So the answer would be choice 3. Next, a transversal intersects two. Oh, do you guys want me to put this presentation on eClass so you can follow along? Okay, I just realized I didn't do that. Let me do that real quick. Let me do that real quick. I mean, and then if you have a printer, you can print it out, but obviously you don't have to. Come on. You've improved on your drone? Are you recording? I am recording. I have students on. Hello. Freddie says hello. He was just flying his drone. Okay, let me upload a file. Where did it go? Okay, if you go to eClass, it's called Geometry Review. All right, so moving on, back. Okay, next. A transversal intersects two lines. Which condition would always make these lines parallel? So we have two lines and we have a transversal. So we're trying to think which would always make them parallel. Vertical angles are congruent. Now this is another example of they tell you one thing which could be true, but the true thing doesn't necessarily answer the question. So yes, vertical angles are congruent, but vertical angles being congruent has nothing to do with parallel lines. So even though vertical angles are congruent, we're going to cross that one off because that doesn't deal with parallel lines. Alternate interior angles are congruent. Alternate interior angles are congruent. That one is correct. So our answer is going to be choice 2. Corresponding angles are supplementary. That's incorrect. Remember, again, corresponding angles would be angle 1 and angle 5 from before. Corresponding angles are congruent. Same side interior angles are complementary. That's false. Same side interior angles are actually supplementary. So that's why we're going to pick choice 2. All right, moving on. Ask questions if you need to ask questions. Based on the diagram below, which statement is true? Is angle, what? We're good? Angle A is parallel to angle B. I'm sorry. Line A is parallel to line B. Line A is parallel to line C. Line B is parallel to line C, or line D is parallel to the line E. So let's take a look. Let's see. A is parallel to B. Well, let's just go ahead and mark a couple things. We know this has to be 110. So that means this has to be 180 minus 110, which is 70. So all of right now I'm doing is just looking at linear pairs. Here's 60. This is vertical angle, so this has to be 60. This has to be 120. And this has to be 120. Because 160 plus 120, 160 plus 120 equals 180. And we know a straight line is 180 degrees. Then I've got here, I've got 115. That's going to leave this at 65. 65 and 115. And then finally on the bottom, I've got 120, 120, 60, and 60. So you're not going to see anything really this in depth, I don't expect, on your unit test, but you might see something like this on like the interim. So all I did is I looked for vertical angles first, then I labeled every angle, and then based on this information, we'll be able to figure out what angles are. So what would be my two parallel lines? Who's got the answer? I feel like I didn't teach you anything. 4, yay, amen, yay, yay. Yes, 4, because we can translate, B would be the transversal, and we can translate this set of angles from D down to E. Yay, that's correct. Woohoo. All right, let's move on. Next, now we're going to look at vertical angles, and now we're going to do algebra. Remember, geometry is just algebra with pictures. So it says in the accompanying diagram, we know that these intersect. That's important for us to know that intersects, because it intersects, we know that we have vertical angles, and we know vertical angles are congruent. So all we're going to do is set these equal to each other. So we've got x plus 5 equals 2x minus 5. So then we just solve. I'm going to subtract 5 from both sides. Or I probably should have subtracted x from both sides in hindsight. Let's do that instead. Well, it doesn't matter. I'm going to subtract x from both sides. That way I can keep a positive x and not deal with negative numbers. So we've got 5 equals x, because 2x minus x is x. And then I'm going to add 5 to both sides in that same step. So this is really going to be 10. So my answer is x equals 10. So, and let's check it. Well, if I put 10 in here, 10 plus 5 is 15. And if I put 10 into here, I have 2 times 10 is 20. 20 minus 5 is 15. So I know the answer is 10. The other thing you could do, because this is a multiple choice question, is we could just plug the values in. We could have plugged in negative 10 and done those types of solutions and then seen what made the most sense. So any of those ways would have been totally fine. Okay, so what type of angles, looking at question number 2, I think we're probably going to be on to like 6:30 maybe. So looking here, what type of angles are these? Who's got the name of those 2 angles? So we're looking at this angle here and this angle here. What types of angles are those called? And I know we're spending a lot of time on this just because you haven't done it for 3 weeks. So if you don't know, that's totally fine. Okay, these are, yay, 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 there they go, alternate interior, perfect, thank you, thank you. Okay, here is, ooh, I just hit my ankle. Okay, so here's our transversal, is that yellow piece. So when we have our transversal, that's our line, and then we pay attention, okay, so what else do we know? Well, that's our line, there's each angles on each side, so it's alternate, and then I talked to you about interior versus exterior. Over here, this is our outside with the grass. The angles are inside, so they're alternate interior. Because they're alternate interior, that means that they, alternate interior angles are congruent. So all we would need to do is set these 2 angles equal to each other. So the answer would be choice 1 in this problem. Okay, what about these? What do we know about number 7? What type of angles are 7? Not vertical. Good guess. Vertical angles form an X. So it'd be like this one here and this one here. So vertical angles, all they do is they share 1 point. They don't share any sides. Same side interior. You could kind of say, nope, same side interior, you have to touch both parallel lines. So it would have to be same side interior would be this one here and this one here. So supplementary from Kyla is correct. These are considered a linear pair. So this is a straight line. There's 2 angles. So when we think of the word linear, we see literally the word line in linear. So it's a straight line, so it's linear pair, so it's supplementary. So all we would do is, I'm not going to do the math, but we would just add these together, and that would equal 180 degrees. Next, I think there might only be 2 questions on the whole test that relates to this whole AKS. All right, the accompanying diagram shows a football player crossing the 20-yard line. I put this in because, you know, everyone's playing like football today. I'm watching NFL. And he's crossing at 30-degree angle. Continuing on the same path, what is the measure of the angle B when he crosses the end zone? And this is just like that problem I showed you in class that was the one that had the building, the parallelogram building, and we were like comparing. So who's got the answer to number 8? And why? So say the answer and then why. One person says 150. Anyone else? Supplementary angles. Okay. Well, if we go up this line, this guy first, he started here, and then he translated here, and then he translated here. So because all we did was translation, 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 it's the same angle. So this is actually 30 degrees. It's 30 degrees because it's going to be corresponding angles. Because all we did is we translated that 30 degrees as the guy ran going up the line. Okay, let's try next one. The accompanying diagram below shows two parallel roads, Hope Street and Grand Street, crossed by a transversal road, Broadway. If the measure of angle 1 is 110 degrees, what is the measure of angle 7? Now, here's another hint that I gave you. Whenever you have parallel lines, and we could have done it here because we could have assumed the endpoints or the lines were parallel. One of the things I talked about is I talked about either doing hugs and kisses or doing obtuse and versus acute. So here, 110 is my obtuse angle. So I'm going to put an O. So I'm going to then put an O next to every obtuse angle that I have. And I know that all of those obtuse angles are going to have to be 110 degrees. Then I'm going to put an X next to every acute angle. And so now that I've done that, I know all my acute angles are going to be the same measure and all of my obtuse angles have to be the same measure. And then it's just a simple subtraction. 180, because I have one obtuse and one acute, minus 110 means I'm going to be left with, yep, 70 degrees. Sanai, well done. 70 degrees. Okay, moving on. Now, so that's the first part of the standard. Here's the next part of the standard. You will have at least, I believe, one question on this. This is the perpendicular theorem, and it's so simple. All it is that when you have a perpendicular bisector, you pretty much are getting side, side, side over and over and over again. It's that simple. So let's take a look. Here it tells us EF is congruent to FG, and we have a right angle. So now we know that here's a perpendicular, and because these sides are the same, we know that these sides down here have to be the same, because when we have perpendicular bisectors, we're just getting the same sides over and over and over and over and over and over again. Now it's just a matter of labeling it. EH is 74. So, trick question, how long is EG? The whole thing. And if you're stuck, look at the next picture to help you. Yes, someone's got it. 148. Perfect, perfect, perfect. That's it. Because these sides are congruent, it creates an isosceles triangle. And because we have this perpendicular, this altitude drawn, that means that each of these pieces are the same. So all we did was do 74 plus 74, and we got 148. All right, next, it wants to know what's the measure of VW. Here's VW. Who's got that one? 15, yeppers. Here's our right angle. So we know that this is isosceles. Again, all of this perpendicular bisectors, just side, 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 side. So this has to be 15. Fantabulous. Next. Okay, so that is, oh no, I have two more. GH equals HI equals 3. FG equals 2. What is FI? Yep, we got a bunch of 2's going on. Perfect. That is 2. And we needed to know that these were 3 just because that allows us to prove and use the perpendicular bisector theorem. So that's why we needed to know these were the same for that purpose. All right, last one relating to this. So now it says, what's HI? So these are the same. So because this is the same bisector, here's our perpendicular. Excellent, excellent. We know this has to be 4. Perfect. Okay, let's go ahead and move on. All right, next it says AKS 12. AKS 12 pretty much deals with triangles. Prove theorems about triangles. These are the things that you have to know no matter what. The measures of interior angles of a triangle are 180 degrees. You have to know that piece of information. You have to know that whenever you have a triangle that's isosceles, except that doesn't look like an isosceles triangle at all, the base angles have to be congruent. Now, I intentionally drew the isosceles triangle tilted because remember, base angles are not always the bottom. Base angles are the angles that are opposite the sides. So for example, if I go here, this side is congruent, so this is one of my base angles going across. Here's my other base angle going across. So it doesn't always mean the bottom. Next, the segment joining the midpoints of two sides is parallel to the third side and half the length. Remember, this was the one day that I was like, this is my favorite geometry thing ever because it's just math and no one invented it. And like, yep. So this was my favorite theorem. This was the mid-segment theorem. All this says that is if this right here is 5, because of this hidden parallelogram, this piece has to be 5. And because of this hidden parallelogram, this piece has to be 5. So it's really just going back and forth and seeing where are the hidden parallelograms, what do I have that's parallel, and what are the numbers. And that's pretty much it. Oh, and then the two medians of a triangle meet at a point. You're not going to have to see a whole lot about that. Okay, here's an example of the first question. First question says, the angles of a triangle are in the ratio of 8 to 3 to 4. What is the measure of the smallest angle? Now, what I haven't really talked to you about before is the smallest angle if we have this being all equal parts. And I don't think you're going to see this type of question on your test, but I still want to go over it because you might see it on the EOC. Oh, Kyle is studying and driving at the same time. I hope you're not behind the wheel, my dear. Okay, so I almost want to pull her picture over so everyone can see, but she's wearing her safety belt. Okay, so here we've got 8x is here, 3x is here, and 4x is here. Okay, so since we know that a triangle has all 180 degrees, what that means is we're just going to set up an equation. We're going to write down 8x plus 4x plus 3x is going to give you 180. Okay? Why did I say Kyla? Kalia is the one who's driving. Why did I say Kyla? All right, nonetheless, so we've got 8 plus 4 plus 3. That's going to give you 15, 15x, and then you would divide both sides by 15 and solve to get your answer. And then whenever you get your x, you're going to put it into the one that's times 3. Let's look here. Here we've got 2x plus 3x plus 4x equals 180. And I'll do this whole one here. So if we've got 2 plus 3 plus 4, that's going to give you 9x. And then we divide. So we know x has to equal 20. And in this case, it wants the largest angle. So the largest ratio is 4. So then we would multiply and get the 80. So again, main thing you need to know is inside 180 degrees, and that's it. Does anyone need me to go over more questions relating to the inside part of a triangle is 180 degrees? Okay, I got a maybe, so let's just do one or two more. Here we've got these three. So we just remember the inside part is 180 degrees. So all I'm going to do is add this up. I've got 2x plus x plus x. That gives me 4x. Here I've got 1 plus 15. That's going to give me 16x. I'm sorry, that's just going to give me plain 16. And that's out of 180. Then I subtract 16 from both sides. That's going to give me 164. Then I'm going to divide both sides by 4. That's going to give me 41. And now I know the value of x, but knowing the value of x does not help me because it wants to know the largest angle of the triangle. So don't always expect it to be drawn to scale. In this case, I would end up filling out every single angle just so you could know the largest angle. So here we've got, this is going to be 41. 41 plus 15 is 51, 56. And then here, 2 times 41 is 82 plus 1 is 83. So that would be our answer, is choice 4. And then the same thing for this one. Just take these 3 angles, set them up equal to each other, make them 180 degrees, and then move on from there. Okay, so the 3 of them being 180 degrees is one of the theorems that you need to know. The other theorem that you need to know is the exterior angle theorem. Now, you don't have to technically know the exterior angle theorem if you just know math, but let's go over a couple examples. Here it says, given triangle ABC with measure of angle B is 62 and it's extended, which value makes AB congruent to CB? So basically it wants to know, how can we get this AB and this CB congruent? Well, in order for that to happen, we need to have these 2 angles be exactly the same. And in order for that to happen, it would have to be an isosceles triangle. So it's like all this working backwards. So how I would do this, the proper way to do this is to say x plus x. Actually, I shouldn't use x. I should use like another variable. Let's do a plus 62 has to equal 180 degrees. And it has to equal 180 degrees because there's 180 degrees in a triangle. Subtract 62 from both sides and simplify. I'm left with 2a equals 118. And then divide both sides by 2. And I'm left with a equals 59. So I know that if this is 59 and this is 59, then those pink lines are an isosceles triangle. Now I have to figure out, well, what does x have to be? There's 2 ways to do it. One, I can use the exterior angle theorem, which says this angle plus this angle here equals this outside angle. The other thing I could just do is know that a straight line is 180 degrees. And I could end up doing 180 degrees minus 59, which gives you 121 as your answer. So sometimes it's just going one step at a time and going backwards. Next. It says in the diagram below, we have a triangle. DB is the median. That's only important because it makes this side and this side congruent. 2AC and AB and DB are congruent. So if it says the measure of angle DAB is 32, what is the measure of angle BDC? Oh, that's tricky. That's also 32, but I'm just going to show you why instead of doing it the official math way. Here's why. Because this angle here is 32, and because this is a congruent side, that means that this angle right here has to be congruent. Then, because this side and this side is congruent, that means these angles also have to be congruent. So that's why that's left with 32. It's a completely ridiculous question that I don't think you'll ever see again. So let's keep moving on. Here, it's the same idea. Do I need to keep doing isosceles questions, or can we move on? Okay, move on. I got one move on. Great, because I'm done doing isosceles questions. All right, next, here's another one. This is the one that's the mid-segment, and you will see a mid-segment question on this, and you'll probably see a mid-segment question on your interim and your district assessment, because it's just one of the fundamental geometry pieces. Okay, so it says here we have an isosceles triangle. We know that these sides are congruent. And it says that we have our midpoints. That's really bold. Here. And we know that this is 3.5. And it wants to know this piece of this. Now, this question is way, way harder than you're going to see on your test. But let's just talk about it. I picked it up for a reason. Because this is an isosceles triangle, we know that the 2 green lines have to be congruent. And then, because this says this is the midpoint, now we know that this right here has to make this 3.5 times 2 to give us 7, because the whole thing with it being the mid-segment formula is that bar 2 small equals the 1 large. Okay, so now that that's 7, all we need to do, and like I said, this is more of an extension problem, is if we know this whole side, let's call this A. This whole side, it's an isosceles triangle, is also A. And then the total is 25. We could just do A plus A plus 7 equals 25. Then we're left with 2A equals 18. If you feel like this is over your head, that's fine. You won't see a question this difficult, but I'm just showing it to you so you get an idea when you see the easier ones. So now that we know that the whole green side is 9, because this right here is the mid segment, we know that that piece here, this x, has to be half of 9, and that's all it is. So half of 9 is 4.5. So sometimes you're just wrapping things around in a circle. The concepts are essentially the same, but then we just keep going. So let's look here. I'm going to skip the perimeter because I don't think you're going to see a perimeter. Here it says EF, looking at number 6, is 2x plus 8. And it tells you AB is 7x minus 2. And it wants to know the perimeter of this trapezoid. Again, this is very similar. We know that 2 smalls equals 1 big. So all I'm going to do is 2 times whatever my small is, 2x plus 8, has to equal my 1 big that's parallel. Okay. And then, interesting. Oh, it says equilateral triangle. That's why. So here we've got 4x plus 16. Then we simplify 18, 3x, x is 6. And because it's an equilateral triangle, all we need to know is one side, and then we can multiply by 3. And it's an equilateral triangle because it told us in the directions. So here we're going to plug 6 in, 42. 42 minus 2 is 40. So we know that each one of these sides is 40. 40 times 3 is 120. So again, step by step by step. Here, this is more like what you might see. AC equals 10. So if this whole thing equals 10, I usually go right on and I just write what all these other sides are. So that means this is 5, this is 5. Because of this hidden parallelogram, that means this piece is also 5. Then it says that AT, this whole thing is 18. So half of 18 is 9, which means each one of these pieces is 9. And then because of this hidden parallelogram, this piece is 9. And then it says CT, this long piece on the bottom, is 22, which makes each of these pieces 11 and makes this 11. So then it says, what's the perimeter of CDOG? So here's C, D, O, and G. So I know I've got 5 here, 11, 11, and 5. So we've got 10, 22, 32 is there. Okay, does anyone need more mid-segment questions? Yes, okay, let's do one more. So we've got AB is 20, so we know this whole long side is 20. Because AB is 20, that means each one of these pieces is 10. Then it tells us, and we also know this piece up here is 10. Because remember, we have one long and the one short. One long equals 2 shorts. So then here it says BC is 12, so we know this whole thing is 12. So because of that, each of these is half of 12, so that means this has to be 6 and 6 because 12 divided by 2 is 6. And then we can also make this 6 because FD is parallel to the CD. And then we have AC is 16, which means each one of these pieces is 8, which means this also has to be 8. So then we can answer the question. The question says, what's the perimeter of ABEF? So I'm going to go here, and I've got here's A, wrong thing, A, B, E, and F. So all those things I'm going to be adding up. So I've got 8 plus, well, here's 30. 10 plus 10 plus 10 is 30. Plus 8 is 38. Plus the 6 right here is 44. So that's the answer. I don't know that you're going to see one this crazy, but that's what you have right now. All right, I think that's all I've got for mid-segment, so let's move on to the next topic. The next topic deals with quadrilaterals, and we did a whole lot with quadrilaterals. We talked about opposite angles being, or parallelograms. We talked about how parallelograms relate to rectangles, relate to rhombuses, squares, kites, isosceles, trapezoids. So the things that you need to know are opposite sides of a parallelogram are congruent. Opposite angles are congruent. Diagonals of a parallelogram bisect each other. And then rectangles are parallelograms that have congruent diagonals. Those are the most important things that you need to know. Do you need to know the other stuff? Yes, for the EOC, but the AKS explicitly talks about parallelograms. Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. And then for it to be a rectangle, you have congruent diagonals or you have right angles. Okay, so let's look at more questions. I want to get to the Kahoot. I'm trying. Okay, so the diagram is Fred here. It says ED. ED is extended to A. AF is drawn, and it tells us these pieces are the same. It tells us this measure is 124, and it wants us to know the measure of AFD, which is this measure here. So again, this is another one of the problems which you could end up seeing, maybe not on this test, but definitely on an interim, where you just have to go step by step by step. What do you know? Well, here, if this is 124, opposite angles in a parallelogram are the same, so this has to be 124. If this is 124, that means this angle, because it's a linear pair, a straight line, we know that straight lines or linear pairs are 180 degrees. 180 minus 124 gives you 56. We know that because this angle is 56 and these two lines are congruent, this angle has to be 56. Then we think of the triangle, and we said, okay, now that we have a triangle, we know that these are both 56. We need the vertex angle. We add the 56s together, we get 112, and then we subtract from 180 to get 68. And I know I did that fast, but this is being recorded so you can rewatch it. But really, it's like they ask you one piece about a parallelogram, and then they mixed in things about an isosceles triangle to get on with what they needed to do. Okay, let's kind of look at another one. Here it tells you, we have the extension. It says CE and BE are congruent. The measure of angle D is 112, and it wants this angle measure. So it's the same process, except the triangle is turned. So if this is 112, this has to be 112. If that's 112, because we have a straight line, we can do 180 minus 112, and that's going to end up giving you 68. Because that's 68, this has to be 68 because it's an isosceles triangle that's flipped on its side. Then I add these up, 140, 136, and then I subtract from 180, and I'm left with 44. So these types of problems is just what fact you know and how can you keep moving around. All right, let's look at a couple other ones. Here we have quadrilateral blue. It tells us that BE and UL are congruent. And then it says, what other information do you need to know? Well, here's what's really tricky. You will see a question like this. You have to know that both sides, both pairs of opposite sides are congruent, or both sets of opposite sides are parallel, but you can't have one of each. So because it says BE is congruent to UL, the other piece of information that we have to have is a piece of information that deals with congruence. So if I've got BE is congruent to UL, my other thing has to be congruent. So right away, I can eliminate choice 1 and 2. Then it says BE is congruent to BL. Well, that doesn't make any sense or help us at all. If that was true, then maybe we could prove a rhombus, but we'd still need one other piece of information. Ooh, this is interesting. BE, BL, LU. I think I disagree with this question. LU and EU. Yeah, I disagree with this question. I think this is a typo because the only way that you could do it is if you would need to have LB being congruent to UE. That's the only way you could do this problem. Because this first thing that they gave you was parallel. If the first thing that they gave you was congruent, then that might be different, but I disagree with that question. Again, which information is not enough to prove? You will have one of these on your test. So it says a congruent and a parallel, that's not enough information. Let's see. We're going to skip these. I don't agree with these questions. Let's move on to the Kahoot because my brain is hurting and you guys have not been engaged, so that's not fair to you. So we're going to do the congruent triangle proofs. So, and plus, I don't think those are right. All right, so we did some of these already. Here comes the Kahoot. Please go ahead and log in. Okay. So go ahead. These are all questions about what other piece of information you need to know. You are going to end up having 2 proofs, I think, on this test. 2 proofs. So this is just to help you with making sure you understand all the pieces. We have a nimble jaguar. Awesome. Okay, let's go ahead and get started. If you're still playing, you can log in. 7 simple questions, and this is the last that we need to go over. Okay, so what are you going to have here? I'll give you a little bit of guidance as you go in. It says B is congruent to D. It says E is the midpoint of AC, so that means we have these are congruent. And we need to know what other piece of information do you need. Well, it already goes over the givens are included. It says that we have a congruent here, so this is an angle. Here we have a side, and here we have another angle. But the question is, so we know we have 2 angles on one side, but does that mean we have angle side angle, or does that mean that we have angle angle side? You have to figure out where are the angles to know if it's angle side angle or angle angle side. Yay! We did pretty good. It is angle angle side because the other angle was the vertical angles. Let's go to the next one. If the triangles are congruent, state what postulate demonstrates that fact. So look at what pieces of information do you have, and then what could be different. Yay! Angle side angle because we have vertical angles in the middle. Well done. And remember, one of your proofs, I think, is a 3-step proof, and the other proof is a 4-step proof. We're almost done. 4 more questions. So, what's the correct answer? Why would you have AC is congruent to AC? That's the question. Why is AC congruent to AC? Waiting on one more person. I'm going to hit skip. Reflexive property is correct. Again, these aren't angles. That's a line. So because this is a line, we know it can't be alternate interior angles. Next. If the triangles are congruent, state the postulate that determines this fact. I think we might have lost our 6th one, so at 40 seconds, we'll move on. Okay, yay! Side angle side, because this is our side here. So reflexive property, side, angle, side. Well done. Why is angle AEB congruent to angle CED? What type of angles are those? Yay! Vertical angles are congruent, kissing fish, and everything else. 2 more. If the triangles are congruent, state the postulate. Ooh, let's look at this media. Here we have an angle. Here we have a side. And because we don't have parallel lines, the only other angle we have is in here. So we know we have 2 angles and 1 side. So we either have angle, side, angle, or we have angle, angle, side. Because this side is not touching the 2 angles, it has to be here. So it should be angle, angle, side if they did it correctly. Yep, they did. Angle, angle, side. It's not side, angle, side because you need to have 2 sides. Last question. What is the correct answer? Why are the triangles congruent? And again, don't overthink it. What is this? An angle. What is this? A side. What is this? A side. Notice I didn't put it underneath the other S. So what's the only thing it could be if you have 2 sides and 1 angle? Skip. Okay, so again, we have the 2 sides and 1 angle, so we remember the song, side, angle, side. So if we mark it off, it has angle 1 is congruent to angle 2, AD is congruent to BC, and AC is it. So then we've got, that should be 3 lines. So we've got side, angle, side. Okay, so that, great job. Great job, great job. That is pretty much all I had for us. Oh, wait, let's see who won. Ooh, we had a 7 out of 7. That's cool. All right, somehow I got logged out of our video. Nope, 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 yep. I don't want to ask myself to join the meeting. Great job. I can't find where anyone is. Return to home screen. Interesting. I must have been dormant enough that I got logged out of Google. So if you can still hear me, hold on, because I don't have that screen up on my anymore. Yay! Okay. Now I'm back. Woohoo! Okay, I can see the screen again. Okay, perfect. I'm sorry, somehow I got logged out by Google, so I lost you. All right, is there any other pieces of information that we definitely need to go over that you feel you just want a little bit more practice on? Oh, it's echoing. Okay, is it echoing now? Okay, perfect. So is there any other things that we need to go over that you need additional help with? I don't see anything. So I guess we're going to end here. Don't forget, tomorrow we are in E412. E412, there are 2 proofs on the test. One is a 3-question proof and one is a 4-step proof. So all the proof practice that you did, plus the review that we did today, I think you should be perfectly fine for the proofs. Can we go over the statements again? Sure. Let me pull something up from eClass real quick and I'll throw it on the screen. So the best resource that you can use to prepare for the test in terms of like what are the different statements and reasons is, remember with the definitions, is if you go to content and we go to rigid motion, there is one of these lines, the full packet, I think, will have it in it. And this is everything that we've done, not everything, but some of what we've done in this unit. And I want to say the last page is the good page. Yeah, so these last two pages here are the ones that are the most important. So things like adding quantities, how you can add, you can subtract in a proof. Substitution. So for example, if I have like something that says x equals 5, and then I have y equals 5, then I can use substitution in saying x equals y because of these two pieces. So that's something to remember. Reflexive property, we've already kind of talked about. You're going to see the angle reflexive property more for similarity, but that's the one that has this line. Partition, basically all that means is you can add stuff together. Down here, any congruent segments are equal, congruent angles are equal, midpoints divide into two segments, angle bisector gives you congruent angles, perpendicular lines form right angles, vertical angles are formed by the intersecting lines, supplementary is 180, complementary is 190, and then CP/CTC would only come into place after you have proved congruent triangles. So you have to have congruent triangles first before you can do that. Things about angles, you've learned that vertical angles are congruent. You've learned all right angles are congruent. You know that if two sides of a triangle are congruent, then the third side has to be congruent. If two angles are congruent, then the opposite angles are also congruent. Down here, I think I missaid this one. If two sides of a triangle are congruent, then the angles opposite. This is isosceles triangle. I'm sorry. That's what that one is saying. Parallel lines, you've learned about alternate interior angles. You've learned about corresponding angles, same side interior or supplementary, and then vice versa. If you have alternate interior, if you have corresponding, if you have same sign, then you have parallel lines. That's what all that is saying. You've learned theorems. You've learned theorems to do the proofs. You've learned side angle side. Side angle side. Why am I not highlighting? Side angle side, angle side angle, side side side, angle angle side, and hypotenuse like. And again, that's right in the content page. So let me see. Is that the last page of my packet? It is. Let's see if I can get to that. Quiz review. Mini packet, load more. Here we go, 20 proofs VIP. So I'm going to throw that piece of information for you right on our main screen. So then that way you got that. Which best is to go through to get to E412 the fastest? Yeah, running's definitely the best. I would say sometimes it's easier when you're in a building, assuming it's not raining outside, to cut and not even go down past B gym to the C to D hallway to keep going. I almost always will walk outside. And so once I leave the door by our classroom, I walk outside like I'm heading to the bus loop. And as long as I'm on time, there's always people entering that door that's right where the buses start. And then you can either go up that stairwell will take you up 3 flights of stairs, and then you go halfway down the hallway to go to the 4th flight, or you can go keep taking that all the way to the end and go up to the 4th stair. So there's a lot of different ones, but yep, it's 4th floor, E4th floor. Let me just add this one more document on here for you guys so you can have that. Let's see, anything else that you guys have that you want to go over before we go? Content. Rigid motion. Docs. Okay, so those proofs are up there. Okay, cool. So I will see you guys tomorrow morning. And you got this, okay? And if tomorrow your grades suck, no problem. Growth mindset, we'll fix it during 3rd and 4th period, and then you'll take the test on Tuesday, and it'll boost your grades up. So you got this. All right. Thank you so much for taking your time on a Sunday to study for math, and I will see you guys tomorrow. Bye.